The next topic that we are going to discuss is perspective projections. The perspective projections, actually it is a type of three-dimensional projection. It is also known as the civil engineer's projection. Why it is known as civil engineer's projection? Uh, it is because most of the larger objects like uh, larger buildings, then whatever is larger than a human being, objects larger than a human being, it is can be represented. They can be represented in perspective projections. So most of the buildings, while they're drawing, the building drawings are constructed, a perspective projection of that particular drawing will also be given. Uh, as isometric drawing is the drawing of mechanical engineers, because most of the smaller engine parts means smaller than a human being. The engine parts which are smaller than a human being are represented using isometric drawing. The perspective projection is used to draw the drawings of create the drawings of larger objects like bigger buildings, then dams or bridges, etc., etc. So let's see what is a perspective projection. The definition, if you need a definition for a perspective projection, it is a geometric technique used to produce a three-dimensional graphic image on a plane corresponding to what a person actually sees. So in this case, what we are drawing is what a person, as a human being, what you actually see a particular object, like an object, a larger object, how you actually sees it. So that's what we are drawing in perspective projection. In the isometric projection, it was a concept. It was not exactly how we see it. And in orthographic projection, it was only a two-dimensional drawing or a two-dimensional representation of the actual object. So in isometric, I mean in the perspective projection, what we draw is what we actually see. So in this case, in the perspective projection, irrespective of in the case of isometric projection and orthographic projection, irrespective of the position of the person who is watching, the drawing will be the same. Wherever the person is sitting, it is or standing, or the viewer is sitting or standing, it doesn't have any effect on the drawing in orthographic projection as well as isometric projections or isometric drawings. But in the case of perspective projection, the position of the observer is important. See any object, if you see any object from one angle, and if you watch the same object from another angle, both the things will be different. The viewer, how you see it will be different. So in perspective projection also, depending on the position of the observer, or depending on the position of the person who is watching the object, the drawing, the shape of the object, the shape of the drawing will be different. So let's see some of the examples in which perspective projections are taken. So there are three buildings given, three shapes of buildings. So in these cases, if you see the first figure, it is Taj Mahal, the photo of a Taj Mahal. In this particular photo, if we come closer to the Taj Mahal, the waterway will become narrower. I mean, not narrower, that the length of the waterway will become shorter, and the building, the Taj Mahal, will appear very closer to us. So that is one sort of perspective. So from which point you watch the object, that is dependent on the perspective drawing. So this case, these are three examples of perspective projections. The first one is a single point perspective. It is known as single point. Why it is known as single point, we will see. Then the second one is a two-point perspective. Why it is known as two-point perspective, that also we will see. Then in the third case, there is auxiliary vanishing points. What is known as auxiliary vanishing points, that also we will see. So see a walkway. This is a walkway. If you watch the walkway, it is appears that at the end, at the other end of the walkway, all the points come together, all the lines, all the lengths come together, so that the lengths become zero. The length appears to, all the lengths appears to be zero. That is all the appears. All the lengths come closer to a point. It is appears to be a single point at the end. So this is how a perspective is drawn, a perspective is described. That is, depending on the position of the person, if we walk through the walkway, it appears is that each these pillars, it appears to grow larger, grow bigger, and then grow high, larger in height. Then as we pass it, and if you turn back and watch the same pathway, then again the same thing happens. The pathway at the end, it appears to be very small, very small in height. So that is the perspective projection. So why this one is another example of a single point perspective. See, all the lines, all the same height lines or same length lines come together to join to a single point, or come together to be end in a single point. That is why it is known as a single point perspective. And this particular point in which all the lines total length becomes zero, this point is known as the vanishing point, because all the lengths then becomes zero at the vanishing point. Every height becomes zero, every width becomes zero, and every breadth becomes zero. So that is why it is known as the vanishing point. So this point is the vanishing point, the end point. See, the yellow lines actually it represents the pillars of this walkway. We know that the pillars of the walkway will be of equal height. It won't be having any change in height in most of the cases. In some rare cases there may be some changes in the height of the pillars, but in most of the cases, or if you look to a building, a large building, from one end of the corridor, if you look, the pillars will be of the same height, but what it appears is that the pillar at the farthest end will be the smallest one, or having the lowest height. So that is the single point perspective. And in the case of double point perspective or 2 point perspective, see, all these lines in this particular building are the edges of the building. Now these edges actually, see, in one side, if you look into one side, all the lines, all the same height. These two blue lines should be of same height in the actual object. But in the drawing, in the figure, what it appears is that the second one, that is this particular blue line is smaller than this one. And if you join these two lines together, the endpoints of these two lines together, or endpoints of any two similar lines together, it can be extended, and those two lines will be meeting at a single point. So this is the vanishing point in this case, in this particular site. In this particular site, this will be the vanishing point. And similarly on the other side, in the opposite side also. Similarly, in the opposite side, if you consider the opposite side of the building or opposite face of the building, then what appears is that in the second face also, in the second side also, it is almost the same. It appears to be that the second, this particular edge of the building appears to be smaller than this one. So there will be another vanishing point towards the left. This is the vanishing point towards the right, and there will be another vanishing point towards the left, and that vanishing point will be this point. So this is why it is known as two vanishing point or 2 point perspective. There will be two different vanishing points in this case. So that is the concept of 2-point perspective. So when we see the object from the center line, through the center line there will be only a single vanishing point, and if we move to one of the sides, any of the sides, and if we can see, or if we can see two different sides of the same object or same building, then in that case you can draw it using only 2-point perspective. That is, there will be two vanishing points will be there. So the previous case it was single point perspective, that is only a single vanishing point was there, and in this case there are two vanishing points, and that's why it is known as 2-point perspective. So the two vanishing points will be of the same height, will be in the same horizontal line, and this particular horizontal line which joins the vanishing points, or a horizontal line which passes through the vanishing point, is known as the horizon line. The horizon line is similar to the horizon that we see in our, if you watch a sea, if you watch a sea from the seashore, there will be a line, a straight line, almost a straight line, where the sea appears to be vanishing. So that we call, that particular line we call it as horizon. So it is similar to this horizon, and this horizon line is also similar to that case itself, the actual horizon. So where we join two vanishing points together, it will be a horizon, a horizontal line, and this particular horizontal line is known as the horizon line. That is, the concept is that the horizontal line or the horizon line will be passing through a vanishing point, or any line drawn through the vanishing point, and the line should be horizontal, then that particular line is known as a horizon line. So the height of the height of the horizon line always corresponds to the height of the spectator's eye. The second condition is that the height of the vanishing point from the ground will be equal to the height of the person, the height of the eye of the person who is watching it, or the spectator's eye, height of the spectator's eye. So now you know that the horizon line will be a line which is at a height equal to the height of the eye of the person who is watching the object. So, and in that particular height the vanishing point will also be lying. So vanishing point as well as horizon line are in the same line, in the same horizontal line, and it will be at a height equal to the height of the spectator's eye, or the viewer's eye. So now let's see the terminology involved in perspective projection. So one is the ground plane. The first one is the most important plane, that is the ground plane. It is the plane on which the spectator is standing, and the plan of the object is to be drawn lies on it. The object itself may also rest on it. In most of the cases, the ground plane is the plane on which the spectator is standing. So the height of the eye of the spectator is measured from the ground plane, and in many cases the ground plane is the plane on which the object of which we have to draw the perspective is also resting. And the second important term is the picture plane. So it is a plane which is perpendicular to the ground plane, and this particular plane, this picture plane, is normally a transparent plane. Why it is a transparent plane? If it is not a transparent plane, we cannot see the object behind it. In most of the cases, the picture plane falls between the spectator and the object. In most of the cases, in some of the rare cases there will be some changes, that is the picture plane will be behind the object, but in most of the cases the picture plane will be in between the spectator and the object of which we have to draw the perspective view. And then the second one is the ground line. The next one is the next important term is the ground line. It is the line of intersection of the picture plane with the ground plane. So you know that whenever two planes intersect, we will get a straight line, and this ground line is also a straight line which is formed by the intersection of picture plane and the ground plane. Then spectator, the person observing the object, that you know, the spectator is who is the spectator, any person who is observing the object, or if there are multiple objects, so obviously objects. Then horizon line. Horizon line is it is a line, as we said earlier, which passes through the vanishing points, and the height of the horizon line above the ground line is equal to that of the spectator's eye above the ground plane. So that also we have described, that is the height, whatever will be the height of the horizon plane, horizon line. So then vanishing point. The vanishing point for any line is found on the picture plane and is located by drawing a sight line from the spectator parallel to that particular line. So if you want to find out the vanishing point of this particular edge, this particular the top edge of this red face, in that case what you have to find out this vanishing point is that parallel to this particular edge, parallel to this edge from the spectator's eye, we draw a line, and when this particular line intersects with the horizon line, or when it intersects with the picture plane, then it is the point which is known as the vanishing point. So the vanishing points for all horizontal lines lie in the horizon line, that we already said, that is the vanishing points for all the horizontal lines lie in the horizon line, but the vanishing points for the vertical lines lie in some other plane, but we are not bothered about it, because we have to draw up to only 2-point perspective. In single point perspective there will be only a single vanishing point that we have seen, and if it is a 2-point perspective, there will be 2 vanishing points, one will be towards the right and the second one towards the left. In this figure also, in this picture also, there will be 2 vanishing points, one towards the left and the other one towards the right. So now the sight lines. The sight lines are the lines, or it is also known as visual rays. The visual rays or the sight lines are the lines or the straight lines drawn from the various points of the object to the eye of the spectator. So if we draw a straight line from the corner of the object to the eye of the spectator, then that particular line is known as the visual rays, or also known as the sight lines. So mostly we call it as visual rays. The visual rays are the straight lines joining a corner with the eye of the observer. Now the points of intersection of the sight lines with the picture plane yields the perspective view of the object. Once we draw the visual rays or the sight lines, then the point of intersection of these sight lines with the picture plane, then that particular points, when you join all those points which we obtain on the picture plane, then that will yield you the perspective view of the actual object. So like this. So these points, this is the actual object, and these are the visual rays or the sight lines, and when these sight lines intersect with the picture plane, those points are joined together in order to form the actual perspective view. And these things are drawn in 2 views. One is a front view and the other one is a top view. We use the front view as well as the top view of the object, the spectator, or the spectator is also known as the station point, then the visual rays, the picture plane, etc., in order to find out the perspective view. So that's all for the introduction. And now let's continue in the next session with uh, exercises to how to draw the perspective views. Thank you.